Hello, my name is Joseph Polkar. I'm a staff multi-cloud solutions architect with VMware. Thanks for joining us for part 2 of this series today. I'm joined with my colleague Matt.
Thanks, Joseph. I'm Matt Elliott. I'm also a staff multi-cloud solution architect here at VMware. And in this video, we're going to be really going through the meat of the migration process with the Cloud Director V2T migration tool. Just to briefly recap what we saw in the first video, we walked through prerequisites of the tool, how it works, basically running the assessment and then going through that assessment and remediating some things that came up. And additionally, some other miscellaneous tasks like changing the MAC address of the NSX-T DLR. So in this video, we're going to start out by having Joseph walk us through the YAML configuration file. So this is a very detailed config file that's needed that provide the configuration to the tool. And then we'll run through all of the migration phases, which is actually what will happen when you migrate from a source to a destination environment. And then we'll look at the optional rollback phase should a provider ever need to perform a rollback of the migration. So with that, I'll turn it over to Joseph, who will begin with the review of the YAML config file.
To migrate an org VDC, we must provide all of the relevant details in the YAML configuration. In the directory where you've unzipped the tool, locate the sample user input YAML, which you can use as a starting point. To save time, we've already filled one out, so let's review our settings before kicking off a migration. As with the assessment YAML file, we'll need to include the VCD, FQDN, and credentials at the top. And in this example, we're going to migrate an organization called eCorp and 2 of its org VDCs. The first org VDC is called Legacy Cloud 01, and we've also provided the NSX-V and NSX-T provider VDC names. You need to create the NSX-T provider VDC in Cloud Director first before running the tool. You also need to provide the T0 name. This should have been created in NSX-T and imported into Cloud Director already. And if needed, you can set the empty IP pool override parameter to true. This was added in version 1.4, and it allows you to perform a rollback without removing the last available IP on the T0 IP pool. If you have any networks that must be routed, you could specify those in the NoSNAT destination subnet parameter, and you'll need to provide all of the NSX Advanced Load Balancer details. You must create your service engine group in the Advanced Load Balancer interface first, then import it into Cloud Director. Here you can specify the name along with the Load Balancer VIP subnet and service network. The VIP subnet will be used for the virtual server IPs. The migration tool will create NAT rules so that the virtual IPs you have configured on the NSX-V side will translate to an IP from the subnet you configure here. After the migration, I'll show what this looks like. The service network, on the other hand, is used to establish connectivity between the T1 gateway and the service engines where the VIPs are actually hosted. If you wish to specify an edge cluster for the T1s, you can specify that on the Edge Gateway Deployment Edge Cluster parameter. You can set advertise routed networks to true if you wish to advertise all routed networks on the NSX-T Edge Gateway. Now, if you're using non-distributed routing in NSX-V and you need to retain that type of configuration, set the non-distributed networks to true. Distributed routing is, of course, the preferred option, but be mindful of the configuration that you have in NSX-V. If routed, non-distributed org VDC networks are deployed and the Edge Gateway firewall is restricting east-west traffic, those rules will no longer be honored after the migration to NSX-T with distributed networks unless the rules are added to the distributed firewall. So keep that in mind. The service network definition parameter is used if you wish to override the default service network, which is used to provide DHCP and DNS on the T1 gateway. You should only need to change this if the default overlaps with an existing network. If you're working with more than one T0, you can specify granular details for each one. However, since we're only working with one T0, which we specified further up in the file, we're going to go ahead and remove these fields. Next, we'll provide the details for the second org VDC called Legacy Cloud 02. The only thing we're changing in this is the service network definition because it overlaps with an existing network. Below the org VDC details, we can configure the name of our dummy external network, which is attached to the source edge gateway during the north-south network cutover, which occurs during the service module of the migration tool. This can simply be an arbitrary port group that you've created in vCenter, then imported into VCD as an external network. And this is really only needed because the NSX-V edge gateway has to have some external network connected. Towards the bottom, you'll need to configure the host name and credentials for the NSX-T manager, NSX-V manager, and the source vCenter, along with a PEM file that includes the signing CA certificate. Now that we've filled out our YAML file, we could start by running the precheck against it. This is done by adding the precheck flag to the command. Here we've also specified the pass file, which gets generated automatically after you've run the tool for the first time. This process normally takes a few minutes to run. Once completed, we should see an indication that the precheck was successful. If not, you'll want to refer to the logs to troubleshoot what caused the precheck to fail.
Thanks, Joseph. With the precheck complete, we can begin the first phase of migration, which is the topology phase. The topology phase prepares the destination environment that all of our org VDCs will be migrated to. This involves creating orgs, org VDCs, edge gateways, networks, and all other necessary components in the destination environment. To kick off the topology phase, run the migration tool and pass the -- execute topology parameter. Notice that we are still including the parameters for the YAML config file and password file. The migration tool will begin building out the target NSX-T environment to mirror the source environment. This process may take minutes or hours depending on the size and complexity of the source environment. If we jump into the Cloud Director interface, the Recent Tasks pane displays each task the tool has completed so far. After refreshing the page, we can see new org VDCs are created, matching our existing org VDCs, but with -V to T appended to them. Now, we'll wait for the tool to complete this phase. Information for both source and destination environments are displayed, indicating this phase has completed successfully. If we browse to one of the original source org VDCs and click on the metadata section, we can see that the migration tool has added many details about the objects that were migrated as part of this phase. It's important not to edit any of these values, as they are sometimes read by the tool as it is performing its tasks. Now with the topology phase completed, it's time to move on to the bridging phase. The bridging phase is an optional phase, but it is available for those who would like to experience minimal traffic interruptions for workloads during the V to T migration. Recall in the first video when Joseph walked through the existing environment, a bridging cluster with an adequate amount of edges was already deployed. Each edge is used to create a layer 2 bridge between source and destination networks. The assessment tool provides the maximum number of networks that will be bridged at once, so you must have that many edges available in the bridging cluster. This diagram is pulled from the migration tool documentation. This diagram depicts a successful migration, so we're getting a bit ahead of ourselves, but it is a good visual of what is built during the bridging phase. You can see the NSX-V environment on the left, the NSX-T bridging cluster in the middle, and the NSX-T environment on the right. So what this phase is going to do is going to build out the bridges that are depicted on this slide. We'll kick off the bridging phase very similar to the last phase by running the tool with the -- execute bridging parameter. Here we can see a bridging edge deployed in vSphere, but it is only connected to our management network right now. Once this phase is complete, we'll see that more NICs on this edge have been connected to facilitate bridging. Again, we'll pause here for just a moment to let this phase complete. While we wait, if we want to take a look in the NSX-T Manager, we can now see a bridging edge profile. If we pop over to vSphere, we can also see one of the NICs has been connected to our bridging edge. Now we'll wait for this phase to complete, and we'll check the results in NSX-T. We can see from the output on the screen that the bridging phase is complete, and if we browse into the NSX-T Manager and into the segment that was bridged, we can see that the edge bridge is connected, and browsing into that, we can see the associated edge bridge profile and transport zone. Now that the bridging phase is complete, we can move to the services phase. Recall that new edge gateways were deployed in the target environment during the topology phase. During the services phase, the migration tool configures these edges based on the configuration in the source environment. This includes firewall rules, NAT, load balancing, IPsec tunnels, and any other configuration supported by the tool. At the end of this phase, north-south connectivity is moved to the NSX-T environment. This is done by connecting the edges in the old V environment to a dummy port group, and the edges in the T environment are connected to the appropriate external network. Now let's kick off the services phase similar to how we've started the previous phases, and we'll let the tool get to work. As the tool progresses, we can pop into the NSX-V environment, the legacy environment, and when we refresh, we'll see that one of our edges has now been connected to a dummy network. Looking in the NSX-T Manager, we can see that our T1 is still not connected to a T0, but we'll see that change here in just a moment. Now, after giving the tool a little bit of time to complete its work, when we refresh in NSX-T Manager, we can see our T1 gateway is now connected to a parent T0. This is what provides the north-south network connectivity in the new NSX-T environment. And now we'll let the tool finish up its work and then view the results. Similar to the previous phases, we can see now that this phase is completed successfully due to the messages that we see on the screen here from the tool, detailing the work that was done during this particular phase. Earlier, Joseph explained how a new IP range was needed for load balancer VIPs. Here we can see that the load balancer configuration has been migrated successfully. The old load balancer VIP is NATed to the new VIP, so the site continues to work as expected post-migration. With the services phase complete, this diagram almost represents where we are after this phase of the migration. Just ignore the fact that it shows that the workloads have already been migrated, which is what we will see in the next phase. But here in this diagram, we can see that the NSX-V edges in the source environment have been connected to a dummy port group. The L2 bridges are in place to provide connectivity between the environments, and north-south traffic has been swung over to the destination environment. Now we are ready to migrate workloads to the destination environment in the Move VApp phase. The Move VApp phase uses the underlying Move VApp API and Cloud Director to migrate workloads, VApps or VMs, from the source org VDC to the destination org VDC. This is basically just using vMotion in the background to move our workloads from source to destination. So let's go ahead and kick this phase off. This should look pretty familiar by now, as we're kicking off the tool in a very similar way to the way we have in the previous phases. Now we'll just pause for a moment so we can wait for the tool to work through this phase of the migration. This phase is almost complete, so while it's finishing up, we'll take a look in vCenter at our destination environment. We can see that some VMs have already been moved over, and if we look in the tasks view, we can see there's some completed tasks indicating what has been done as we've gone through this phase. If we browse over to our load balancer VIP, we can see that this is still working as expected post-migration. Just like the other phases, we receive a message with a summary of what tasks were completed during this phase, and a message indicating that this phase was successful. With that, I'm going to hand it over to Joseph, who's going to walk us through the cleanup phase.
Thanks, Matt. Now that everything in our two org VDCs are migrated, the last step of the tool is cleanup. This is the time to double check the configuration and perform any tests necessary to deem the migration successful. The cleanup step migrates all catalog items, removes layer 2 bridges, and removes the source org VDCs. To start off, let's look at our legacy Cloud01 org VDC and confirm our configuration looks good. We can see our 3 virtual machines, our Web Cities vApp, and our source org VDC network. Let's take a look at the edge configuration. The edge cluster we specified in the YAML file was used. Our firewall and NAT rules were carried over, so that all looks good. We can also check our load balancer configuration and confirm we have the proper service network and service engine group configured. Under virtual services is our Web Cities VIP, which points to the Web Cities pool. Notice the virtual IP ending in 129 has been allocated from the service network that was provided in the YAML file. If we look at the advanced load balancer web interface, we can see the Web Cities pool. We can browse to the original IP that we had configured as the load balancer VIP on the NSX-V side, which ends in 102, and confirm the website is up. And refreshing the page causes us to hit a different server in the pool. So this all looks to be working. This is possible because the tool automatically added a DNAT rule, which translates the original VIP to the new VIP. We can see what that rule looks like here. Now that we have validated our configuration and confirmed all services are up, we can run the cleanup module of the tool by using the -- cleanup flag. This will remove the org VDC resources from the NSX-V backed provider VDC and rename the migrated objects to remove the -v to t flag. In this example, we received an error when attempting to delete the bridge transport zone. In some cases like this, you might need to perform some manual cleanup activities. When we try to delete the edge bridge profile, we get an error that it's still being referenced by the V to T demo segment. If we take a look at that segment, we can see that it does in fact still have the edge bridge configured, so let's remove that. Now we are able to delete the edge bridge profile. That still leaves the bridging transport zone. If we try to delete the transport zone, we can see it is still being used by the edge transport node. Let's delete that bridging edge node first, after which we should be able to successfully remove the bridging transport zone. Now that we've cleared up the bridging objects, we can rerun the same cleanup command, and the tool will resume where it left off with the cleanup process. Once completed, we can confirm the original org VDC has been removed from VCD. This was the last step in successfully migrating an org from an NSX-V PVDC to an NSX-T PVDC. If at any point you deem the migration unsuccessful, or wish to revert back to the NSX-V org VDC for any reason, you can run the tool with the rollback flag. In this example, the rollback is being performed after the services module is run, so we can observe the NSX-V edge gateways being reconnected to the external network. We do end up getting a few errors related to an org VDC network that needed to be removed in this case. So I needed to manually clean up some of those objects from Cloud Director. After removing the org VDC network, I reran the rollback command and it resumed where it left off. Finally, we should see an indication that the rollback was completed successfully. That concludes our overview of the NSX-V to T tool for Cloud Director. For a recap, we've gone through all the modules of the tool, including topology, bridging, services, move VApp, and cleanup to successfully migrate an org VDC from NSX-V to NSX-T. Remember, you can always run these modules all together or use the breakpoints like we did to have greater control over each step of the migration. Of course, if at any time you need to roll back or you run into problems, you can use the rollback capability to revert the changes. Matt, did you have anything else to add before we conclude for today?
Just wanted to say that if you found this video helpful, then please like and subscribe. Also, check out the links that are in the video description that will take you to our Tech Zone page, which will have this videos and many others linked that are relevant for providers, as well as the YouTube channel that you're on right now is full of other great content if you haven't browsed through here before. But with that, I just want to thank you for your time and watching these videos. If you've got any questions, again, please leave a comment. And thanks. Have a great day.